Hello and welcome to a video lesson about classes. This is going to be the slideshow portion of the lecture. The other part of the lecture is an implementation of classes. So I'm going to just jump right in. Let me go ahead and move my mouse over here. So object-oriented programming, or OOP for short, views a program not as a sequence of actions, but as a collection of components called objects that interact with each other to produce some sort of means. A group of objects of the same kind are said to belong to a class, which is a programming construct that defines the object's data type. So instead of having a double, you might create a class of animals, and then they'd be of type animal. You might create a class of type, calculator, and that type would be calculator. So instead of having a double or an integer or a string, you've created your very own data type. It's very exciting. So in the examples that we're going to see in the slideshow, we're going to use something called a sphere class. You may have heard of this item. The world is supposedly a sphere. Many round things are spheres. So we're going to use a ball as an example of an object. Because thinking of a basketball or a volleyball or a soccer ball probably suggests images of the game rather than the object itself. We're going to abstract the notion of a ball by picturing a sphere instead. So a sphere of a given radius has attributes like volume and like surface area. A sphere as an object should be able to tell you what its radius, volume, or surface area is. And the sphere object needs to have methods that return such values. And that's covered here. But before we move on, I wanted to note that by default, all members in a class are private, meaning that they're not directly accessible by any part of the program unless you designate them as public. So here you have a section for the private member variables and private methods, and then you have a section for public methods. So just remember on the quiz, by default, all members in a class are private unless you designate them as public. And classes have special methods called constructors and destructors for the creation and destruction of its objects. A constructor creates and initializes a new object or an instance of a class. A destructor destroys an instance of a class. We're not going to use them here. For many classes, you can omit the destructor. Most of the time, the compiler will generate a destructor for you. So let's get into it. So you start a class by using the class keyword, and then you say the name or you write the name of the class, and you want to capitalize the first letter if you can. And then you establish things as private or public. So what you need to do is create a header file. And this is going to keep track of all of your definitions that are associated with your class. So in this example, we have a private member variable radius, or the radius as the book says. That's kind of funny. And then we have public methods like the constructor here, the sphere, the thing that makes the object happen. We have an overloaded constructor that takes an argument, an initial radius. We have a setter to set the radius. We have a getter to get the radius. And then we have a few other methods that are going to go along with our sphere. So go ahead and read through those when you get a chance. And if you're not sure if you should have something as public or private, just make it private. Yeah, no one's going to fault you for that. Okay. And the implementation file is where you write the definition, where you write the implementation of the definitions that you defined here in the header file. So you're going to take all of these and you're going to write the implementation. Okay, this is what this function does. This is what this function does. You're going to write them in the implementation file, and it's going to be called the name of the class .cpp. whereas the header file is going to be the name of the class .h, and that's a convention that you're going to be using. You're going to notice in this example that there's 2 colons here. This is called the scope resolution operator, and you type in the name of the class, then the scope resolution operator, and then the function. In this case, it's going to be a constructor. You put the data type, in this example, it's void, then the name of the class, then the scope resolution operator, and then the function. And in this particular example, there's some sort of a check that's occurring. And this is really good because this is checking for unusual user behavior. If the radius is greater than 0, then we're going to establish the radius as the value. Otherwise, we're going to set it to 1. So this is very useful whenever you have people who are nitpicking in your program and making inputs all wrong. You have handlers that take care of that. And then some other methods that just perform just basic calculations. Oh, and the getter here returns the radius. So in the quiz, it's going to say what's a getter and what's a setter. Here's what they are. This one sets a value. This one gets a value. Pretty easy. And then we move on to the concept of inheritance. So you're not going to get quiz super heavy on this, but the idea that you want to reuse classes that you've made before and make subclasses or base classes and subclasses. So this here, I just want to make sure that I'm getting the terms correct. The class sphere is going to be called the base class or the superclass because we're going to build on top of it. We're going to build sphere in color to be a subclass. So this is just, you notice that it has public sphere here, and then looks like a new class. It's a subclass. So it's like a derivative of sphere. It has all the things that sphere does, except more things. And that's what inheritance does. It takes what you have from before in your classes, and you're able to add on to it. So that's kind of what inheritance is. The book itself says about as much about inheritance. I'm just double checking to make sure so that I don't miss anything. And then, yeah, so here's a header file for an inherited class, a subclass called sphere in color. And then here's its implementation. And then here's a use case for it. But we're actually going to look at Visual Studio. I have something up here. So I coded the lab and I created, let me maximize this, I guess. And I created a subclass called cube in color. So the lab that you're going to work on this week, depending on how you do it, can be a little bit long. It is quite fun though, so I think you'll enjoy it. And the lab is to create a cube or a cylinder to allow the users to enter in which they want to pick, a cube or a cylinder, and then they enter a side. But I've augmented this solution to include a color choice if the user picks a cube. So something cool about that is that I created the subclass here. I even created some enumerations for colors that you can use. And then notice the same way that you saw in the slides, that's the same way you create a subclass. So we define public cube, so the superclass, a colon here, and then in the beginning, your new class, and then the class keyword. I think that's everything. So I'll go ahead and post the solutions for the lab next week. If you need to see them sooner than that, just let me know and I'll get them to you sooner. But that is everything I wanted to tell you for now. We will talk a little bit more about this into next week. But for this week, I want you to practice creating classes and subclasses. And if you get any errors or anything wrong with your code, just send the code over. I'll take a look and we'll clear things up. So thank you so much for listening and have a wonderful day.